All right, we're going to look at a problem that gives you this mechanism, and then the question just asks which of the following are true. So what I'm going to do is just completely analyze the mechanism, and then we can just figure out which facts, or you can figure out which facts are true from the statement. So it's only a two-step mechanism, so it's short. I need to identify the items that copy each other as both reactants anywhere and products anywhere, because those will be catalysts or intermediates. And it turns out that the only copy is N2O, the dinitrogen monoxide. All right? Nothing else duplicates from one side to the other. All right? You'll notice that there are two H2s, but they're both reactants, and I cannot eliminate them unless one's a reactant and the other is a product. All right? So in order to write an overall reaction, I'm going to bring down all of the items that I have not eliminated. All right, so there's my overall reaction. All right, I brought down two H2s and my two NOs. All right, and then I also brought down the one N2 and the two H2Os. Now, one part of the question asks about the balanced mole ratio. All right, well, here's the balanced mole ratio. Remember, you just list off the coefficients. So see if that's true or not. Another item that we might be, that it refers to is the energy profile. If you remember, the energy profile is going to be a simple graph that shows a number of humps equal to the number of steps, with the slow step being the taller hump. So you'll see, you can see my energy profile there. All right. Not only does it show 1, 2 steps, but the first step is very obviously the slow step. A part of the question asks you to locate where an intermediate might be. Remember, an intermediate is any item that's a product and eliminated, just not in the last step. If it's in the last step, it's a catalyst. So here we have an intermediate at the end of step 1. So in my energy profile, here is the end of step 1. And again, there's no catalysts in this example. The rate law is going to focus exclusively on the slow step. All right? So I'm going to go over to the reactants of the slow step, and keep in mind that in the rate law, not only will we include those reactants, but the coefficients of them in that step will be the order. So you can see that it includes both of these guys, and the nitrogen monoxide is raised to the power of 2 because of that coefficient there. Remember, if the overall reaction would have included a reactant that is not in the slow step, we would include it in the rate law raised to the power of 0. All right, so I think one of the questions asks about the orders of the rate law, so just make sure you look here to answer what's true about that. And then finally, it wants to know what is the order of the overall reaction. In order to find the order of the overall reaction, we simply take the sum of the orders of the rate law, which means I would go 1 plus 2 is 3.